Coming up on This Week in Computer Hardware, so much Computex news, AMD Ryzen 3000 CPUs and 5700 series GPUs, Zombieload patches, shwack, Intel CPU performance, how much, PCI Express 4.0 SSD performance, and more. It's all coming up next on TWiCH.
Netcasts you love.
From people you trust.
This is TWiCH.
This is TWiCH, This Week in Computer Hardware, episode 519, recorded on May 30th, 2019. Ryzen 3000 and Zombieload's impact. This episode of This Week in Computer Hardware is brought to you by SmartDeploy. SmartDeploy allows IT departments to re-image unlimited computer models from one golden image. Search their library for your models and get 15 free licenses with 1 year of support. That's $720 worth of free IT software at smartdeploy.com/TWiCH. Welcome to TWiCH, This Week in Computer Hardware, TWiCH weekly show that aims to bring you all the hardware news, and I got to get to it because it's Computex week. We have huge announcements, and normally I'd tell you all sorts of things about what we do here, but let's talk about hardware. Sebastian Peak, PCPro.com editor-in-chief. What was your favorite, biggest, most important announcement of Computex? I bet it's from either AMD or Intel.
Well, it's got to be AMD stuff, and of course, they didn't just have CPUs to talk about. They also teased us with GPUs, which we'll get to, but biggest news for me coming out was finally getting some real details about the upcoming Ryzen 3000 stuff. And we already knew from CES, we knew from leaks, and whatever they've announced previously, this is going to be 7 nanometer, of course. This was going to be the new chiplet design, which they showed on stage at CES. But now we have product names, clock speeds, core counts, and a very impressive 15% improvement in instructions per clock, or IPC, over the last generation, which was surprising, I think, to a lot of people when Lisa Su announced that during her keynote, because the thing holding Ryzen back in the past, if you were actually speccing out, say, a gaming build, was Intel had a pretty significant advantage in IPC. Yeah, that single core performance.
Let's unpack this for a second, right? Because 15% doesn't sound like a lot, because Intel got 18% over Ice Lake, except that the 18% number for Ice Lake was based on a 4-year-old processor by comparison.
Okay.
Instructions per clock cycle, I'll double check, but instructions per clock cycle is something that we haven't seen. It has been like the big deal in terms of all the announcements in the last week, because I feel like I haven't seen that ever up front in keynotes like this, and all of a sudden I'm seeing it everywhere. And a long time ago, everybody, companies still sold by megahertz, but everybody knew that you could have a faster processor because it had a higher megahertz rating that was actually, or gigahertz, but that was actually slower than another part. Now, instructions per clock cycle is a way of saying, like, every time the clock goes over, we do this many things. And if you do more things, then you get more work done, and more work done equals a faster real world performance on most benchmarks, to grossly oversimplify. 15% over previous generation, that's huge.
Yeah, and it's not just coming from clock speeds, obviously, because there are some really good clock speeds here, and they are higher than the previous generation. They're well over 4 gigahertz with their boost clocks on these parts, but they've done some refinements to the architecture. Zen 2 is not just a die shrink to 7 nanometer, clearly, and they talked about the fact that the cache sizes are going to be bigger and doubled, in fact, and the floating point performance they're claiming is 2x the previous generation as well. So that's where they're getting their uplift in IPC, that and the clock speeds. So you were talking about the old days with the gigahertz wars. Simple instruction set computers were often faster than complex instruction set computers, where you had these, for example, like the Pentium 4, the early Pentium 4s were nowhere near as fast as some of AMD's parts at that time. And they were getting through a shorter pipeline and getting more stuff done per clock cycle. And there was that perception of greater speed, even at the same megahertz or gigahertz number. So it's really interesting to see the IPC improvement, because it'll totally change the argument about gaming. And we'll do a lot of gaming benchmarks, and we'll see, because that was the one area where you could get an like a Core i7 8700K and have significantly better IPC for games that weren't really multi-threaded as well, or not as optimized for AMD hardware. And then, of course, AMD was always showcasing games that were games like Ashes of the Singularity, which are extremely, optimized, multi-threaded, and took far better advantage of Ryzen CPUs than Intel was basically taking up everything else. Anything that was single-threaded, heavy, or just relied on IPC. So, it's. Go
ahead.
No, I'm just saying, like, it's we don't know all the details, and we're going to learn more, and we really have to benchmark to know. But I won't say like they've completely solved the problem, because at one point there was about a 20% disparity between Intel and AMD when Ryzen first launched. But it's going to be very interesting, and to see especially what Intel can come up with on desktop to compete with this.
Right. I mean, so part of the challenge of looking at this and looking at Intel's benchmarks is, this is the first major architecture release since Skylake came out in 2015, right? That was kind of their big point. It's like Merom, Nehalem, Sandy Bridge, Haswell, Skylake, Ice Lake. Ice Lake's running on 10 nanometer, which is exciting. But the numbers I'm looking at, when you get the Sunny Cove instructions per cycle, which is the name of the new microarchitecture, it's ISO frequency performance versus SKL core, and you see this line, and the line is going. My loose understanding is that 18% is based on some of the older processors. They don't get real granular in the benchmarks, and that was one of the things I kept thinking about over and over again when we were talking about this on Tech Thing earlier this week. Is I want to see real world benchmarks. I want to see real world benchmarks because. Everybody's promising a lot, which is hardly unusual for an event like this. But it's we're looking at some really amazing numbers, and especially in terms of the Ryzen, like I am blown away, because I was looking at this and thinking, like, $499 for 8-core. 16 thread, Ryzen 9, 12 core, 24 threads. That's the 3900X for $499. Intel's 8-core, 16 thread i9 9900K is $488. And if they have really jumped, the single core performance, the instructions per clock cycle up as much, that is going to be really interesting to look at benchmarking wise, because that could flat out eliminate a lot of the disparity we've seen between the two parts. The other thing it was looking at it was interesting looking at the Intel's announcement of like the Core i9 9900KS, because I wonder if this reeks of something where they knew the Ryzen 3000 performance was coming, and they wanted a part where they could throw out like, this is the ultimate gaming processor, because the 9900KS, the Core i9 9900KS, 8 cores running at 5 gigahertz all the time is what they're saying. We don't know what the pricing is. We don't know what the TDP is going to be, but I bet it's going to be impressive. I also want to see the real world, because one of the things I think you enjoy is like, okay, this is a 95 watt part, and it ran up to 155 watts during our benchmarking testing. Because, why not underestimate the power consumption when you flat out run everything by 50%. But in theory, like the 9900KS, like the base frequency is 4 gigahertz. They claim they'll run everything at 5 gigahertz. But it's gonna be impressive to see whether or not Intel can release this part without doing the classic Intel. Well, it's going to be $1,200. It's going to be $1,500. I'm very, very curious to see what that sells for. I'm also, because these are essentially like, these are bin sorted. It's, they're going through, they're testing them out. They're bin sorting them. They're finding the chips that are comfortable with operating at this level. I think availability is going to be really scarce, and I am very curious to see what the real world performance looks like on that, especially given the overclocking success we've had with the Ryzen CPUs. I mean, this looks challenging for Intel. This looks like a really intense summer for Intel.
It's the landscape has gotten a little cloudy. Like at one point, it was pretty clear. Ryzen offered more cores. Maybe it wasn't as high IPC, but for the same amount of money, if you're doing work like rendering and transcoding and anything that required a lot of multi-threaded performance, that was the way to go. You've talked about that a lot in the last few years. Just the idea of getting that many cores that cheap was just a revelation. It was the way to basically spend desktop money and get a workstation. And a lot of people were still recommending or building, or we were still reviewing Intel parts as being a better solution for gaming, which is, a lot of what we do here. We benchmark graphics cards and latest games that come out, and we still use Intel parts in our test benches because you don't want to be holding back a new GPU because you don't have the IPC. And that could change. It could absolutely change. The entire landscape could look different in the next year or two, which is very, I don't know. It's kind of scary and exciting at the same time.
But consistently so. Well, let's talk about, speaking of scary and exciting, we had the CES announcement. I think both of us were expecting the Ryzen 3000 to be announced at CES. Instead, we got the 7 series, the semi-pro, the prosumer GPU from AMD. And now we're looking at their actual first, consumer Navi GPUs, the 5700 series. Not a lot of information on these. More information expected at E3 in July. It's certainly radically different from the rumors that were floating around last week.
Yes.
But, 1.5 times the performance per watt, they're claiming 1.25 times the performance per clock. They're getting out of the RDNA architecture. There's a lot going on here. Also, PCI Express 4.0 support, which we'll talk about more in a couple minutes. But this is, they're making some big claims on this coming in July. The 5000 series, everybody was kind of. It's funny because the Anantech article they took pains to point out that this is a big, this isn't Vega, this is Radeon 7, this isn't like Unicorn Fart 4. They're like series numbers and blunt force, like, oh, look, we're going to do a much bigger number. You think 2800 sounds great? You think 2800 Ti sounds better? Fine. We'll go to 5,000.
Well, I think they may have been forced to go to 5,000. I had read some things about NVIDIA possibly trademarking a whole bunch of product names, knowing that AMD hadn't released anything publicly yet. So AMD is trying to spin this as, well, it's our 50th anniversary, and they have like the 50 highlighted in the 5,000 name.
Right.
But they haven't had a 5,000 series part in a long time. And we had the HD 5870 and all of those parts just a few years ago. So it's funny to see them go back to 5,000 again already. And of course, I see RX 5700 and my mind makes that FX. And then we think back to that lovely FX 5000 series, like the FX 5200. And, those were NVIDIA chips. So, it's just a product name. Most people who don't have years of experience with this stuff are not going to make those, comparisons in their mind. But it was funny to see, like, the rumor was it was going to be the 3080. They leapfrog Intel and have a 3000 series part to compete with their 2000 series parts, but 5,000 is a bigger number. So obviously that means it's better, right?
Right. Well, let's talk about this, right? The AMD, I guess they took 30 games, testing at 4K, 3840 by 2160, ultra settings, 4x anti-aliasing. And they said it was 25% faster than a Vega on a clock-for-clock basis. 25% gain in performance is kind of a big deal right now.
We were just talking about 15, so this is obviously a lot better than that. Clock-for-clock, we're talking about IPC. And, one of the things about moving to 7 nanometer, because this is going to be a 7 nanometer GPU, is you kind of have some options. You can try to be more aggressive with clock speeds, with that bigger thermal envelope, and you could also be a lot more efficient. So it's great for mobile parts. If they're striking a balance and still finding that kind of IPC improvement, that'll be really impressive. Although getting that much additional performance, we might be looking at a similar situation to Radeon 7, which was a GPU that outperformed Vega by around the same 20-25% number, but was still pulling 300 watts. So, you know, they could be pushing the very edge there.
You know, they were talking about, you know, a 50% increase in performance per watt is the equivalent of saying we've reduced the wattage consumption by half for a given performance. I mean, you know, this is yet another thing. We're not going to know what the real story is until the product actually ships, and you know, you start beating the snot out of it with benchmarks. But you know, this is you know, it's going to be a real good July if they ship everything and they have volume. It's going to be a really good July for you know, for AMD. They were a little vague. They had very little information about a test board running against an RTX 2070. I like to call it, you know, I have to look it up because I keep trying to call it something different, not entirely family friendly, but Strange Brigade, which is a game that normally offers a bit of a performance benefit or is favorable to AMD in terms of gaming performance. But they were showing it off against an RTX 2070. And, you know, we won't know until E3 what exactly the pricing is and the exact release dates and how it compares. You know, I think they're probably hammering on the drivers on this as fast as they can. You know, I suspect these will be all over the place at E3. I'm suddenly like, oh, I don't want to go to E3, but boy, this is really tempting.
Yeah, and especially if some of the rumored prices are accurate, because that's really the crux of the matter. Is you can offer whatever percentage performance increase, but if they're offering this at a very compelling price and undercut NVIDIA, then it becomes a lot more interesting. And they showed that 2070 demo. There have been rumors that they were showing the 2070 because they were going to bring it out to compete with the 2070's price point, which would mean this first 5000 series part, if it's the 5700 or whatever it's called, is going to be $499 with, or maybe that would be, I think that was the 80 series part. But some of these rumors are back when we were looking at 3080 and 3070 as the rumored names with those prices. So somewhere between $399 and $499, but none of that has been confirmed by AMD. And like you said, E3, we have to wait a couple more weeks until their big event that they've teased. I believe it's the new Next Horizon is the event name at E3. So I'm sure they'll be giving us product names and pricing, and then we'll have obviously a lot clearer picture of what to expect.
Goodness. The other big announcement to kind of complete the processor announcement at Computex was the announcement of the 570 chipset. And there's a chart, which I don't think there's a... WCCF Tech did the painful and exacting work of collecting sort of all the announcements. For example, the Aorus, ASRock, MSI, Asus, you know, the volume of motherboard releases has often been emotionally traumatizing, more so on the Intel side than the AMD side. You know, ASRock has 10 motherboards in their 570 lineup. You know, this article just kind of keeps scrolling on forever.
Yes.
Yeah, Asus was, you know, had a rather large pile of motherboards. The thing that really strikes me about this is pretty much all of the second-gen Ryzen chipsets will cheerfully run the Ryzen 3000 CPUs. Some of the very earliest chipsets promise to run a Ryzen 3000 CPU if they get a BIOS upgrade or firmware update. They haven't changed the socket, which makes me so happy. Because, you know, there was this like 6-year span of my life where every other year I was buying a new motherboard, you know, because Intel had changed the socket around, or at least it felt that way. But this is, you know, This is, I mean, are you if you want PCI Express 4.0, you will be buying an X570 based motherboard. Are you excited about this? Are there any things that really stood out on the chipset for you?
Well, they talked about improved connectivity, and that's what we'd heard about for a while. Of course, it's going to be bringing PCIe 4, and that's to the chipset. The processors themselves support 16 lanes apiece. If you need more than that, and for a lot of these other solutions, you're going to want the newest chipset. Like if you wanted a PCIe for SSD or a couple of them,
right,
and you're running GPUs off the Gen 4, then you're going to run out of lanes. But yeah, I mean, some of the features, it appeals to me, the fact that they developed this chipset and that they've focused on things like connectivity, because historically that's been one area where you might have favored an Intel solution for better like consistency with your piece, like your USB connectivity with storage speeds in general.
Right.
And they're not relying on just like an off-the-shelf as media solution for things. This has been tailored, and they've worked on this themselves. It does require a lot of power, though. It was one of the interesting things about this chipset launch is they're going up to 15 watts from the chipset.
Whoa.
Which means you need active cooling. It's like those old high performance boards from, I don't know, I'm thinking like of old Enforce boards and stuff, but
right.
Even the little mini ITX boards, and my favorite one so far is the Asus ROG Crosshair 8 Impact,
right?
Which is, it's not quite a mini ITX board. It's, I believe they're mini DTX. I've seen this motherboard form factor once before on an ECS board, but it is a little bit longer than mini ITX, but still fits in ITX cases that have 2 expansion slots, so just about all of them, which pretty much will hit the case floor, but it will fit. And there's a little fan in there, and this is just ridiculous to think that you could put one of those 12-core parts in this and have a little mini ITX rig. But yeah, every vendor, and of the big 4, certainly, and we had in X470 boards, if you go to Newegg right now and go shopping, they're, Asus, Gigabyte, MSI, and ASRock, and those 4 have released just a flood of these new motherboards. So X570 is very, very well supported out of the gate, which is a really good thing, because I'm thinking about some of the earlier Ryzen launches and just a couple motherboards per vendor and issues and BIOS updates. So hopefully this is a nice, smooth launch.
Or desperately needed BIOS updates that seem to take forever to get out. There was some, especially with the initial launch of the Ryzen CPUs, it was a little painful because they're past that now. It seems like a bunch.
Yeah, go ahead.
I was gonna say, it seems like a bunch of the initial AMD motherboard release, or the Ryzen motherboard releases, were done as sort of a courtesy. We've been with you for so long. Of course, we'll make a couple motherboards for your new CPU. That's so cute. And then they started selling a lot of them, and then Intel started having supply issues, and AMD kept coming out with faster and faster processors. And I think it's gone from being like, we're doing you a favor to, hey, there's an opportunity here, and we need to not screw it up, which I'm okay with, quite frankly.
I can't remember which brand it was now, but one of them, we were talking about BIOS updates a minute ago. That was so painful, because I remember at least one instance where I'd put together a system, and the only way to install the CPU that I had was to put an older generation CPU in, run a BIOS update, and then install my new CPU, which I didn't have. So I ended up buying an older generation CPU just to do this. I think at least one vendor was sending out CPUs to allow people to upgrade their BIOS, but at least one vendor with this new launch was actually offering BIOS updates without a CPU, RAM, or video card installed. I think it was either MSI or Asus, but that just
sounds exciting.
That will probably not be necessary, because they've had longer to work on this chipset. There were speculation about maybe AMD didn't give vendors very much time the first time around. Which is why we had so many issues with those boards, but it's smoothed out with 2nd gen, and it should be even better with 3rd gen.
I'm okay with that.
Yeah,
I am totally. I'm I'm going to pre-order a 3900 like the minute they are available because I'm that excited about them. You know, Intel launched 10th generation core processor with Generation 11 graphics. This was probably the most important announcement that Intel made. The Iris Plus graphics are the graphics are a much bigger bump than any other aspect of the performance of 10th gen Ice Lake mobile processors. You know, and I think Intel's keynote was kind of all about that. That said, they are still not. They are a better device for playing Rocket League, for example, but you're still not going to be playing top of the line 3D games on your ultra portable with Intel factory graphics.
No, and I think, and obviously they're very proud of any lead they can get over any of the Ryzen APUs, but this is, you know, give consumers a great experience with productivity and also give them the ability to run games, which is something that, you know, Ryzen APUs can do, but maybe Intel can hit some better power numbers. We're looking at, I know some of the lower power APUs in the Ryzen stack are 35 watts. And this is, you know, 9, 15, and 28 watt parts. So if they're a little bit more efficient, maybe even at the same graphics performance level, that would be appealing in a laptop format. One of the things I also point out about this is the memory. We're seeing already, there's at least 1 or 2 laptops that have launched. It was a Dell XPS model we'll talk about, but LP DDR4X onboard memory speeds of 3733 megatransfers per second. So really, really fast memory coupled with improved graphics is going to help a lot. And that's something that's not as common in mobile, where on the desktop, I've experimented a couple of times with overclocking the snot out of either DDR3 or now DDR4 memory to see immediate and sizable gains in graphics performance from an AMD APU, where, you know, there's just no contest between the results from even like 3200 megahertz versus the default 2400 megahertz, because they're so bandwidth starved when you're supplying the graphics RAM from system memory. But to go up to 3200 as the standard and then the 3733 from this soldered memory on these motherboards is going to be huge. And that's probably as big a part of the story as anything. And they're not really talking about that as much because they're talking about how many EUs it has. And it's like the most they've ever had or tied for the most they've ever had at 64. The Gen 11 graphics look very impressive. They've worked on the architecture, and, you know, it's already, I would have looked at an Intel laptop because they offer really good like performance per watt numbers, and we don't have any 7 nanometer stuff from AMD yet. They're focusing on desktop, and their mobile parts are still on Zen Plus. So I think once AMD has their desktop kind of in full swing and everything is like 7 nanometers running at like full capacity, then maybe they'll introduce some mobile parts to compete with this. But the stuff that Intel is showing, any comparisons they do to APUs, they're talking about either small form factor desktop or, you know, there are a few laptop models out there, very few, that use an AMD like APU solution.
Right.
So,
well, I mean, it's interesting, and I should also point out that Intel clearly states on one of their slides that it will be able to play Fortnite.
oh, well, there you go.
Popular
That's
games like
matters.
Fortnite and Dirt Rally at 1080p gaming with an asterisk, and of course, I can't find what the asterisk leads to. But
yeah,
you know, the other
Fortnite
thing
is basically Minecraft. Like it's
right.
It's that game that millions of people are playing that isn't especially challenging to run on just about any hardware. So,
but if you could, you know, if you can play competitively on your new, you know, laptop, that wouldn't be a bad thing. I don't know. I think I'm mostly excited because I've had a bunch of different network folks talk to me about Wi-Fi 6 testing, and me being like, gotta wait till something ships with Wi-Fi 6. So at least that's coming out in the next generation of processors, along with Thunderbolt 3. you know, M15. Didn't we just do the last round of Optane memory? Because the M15 series Optane memory, faster speed, lower latency, and using 4 PCI Express lanes for the first time. What's the real world potential impact performance wise, you know, for the M15 versus the, it seems still so young, M10 series of Optane memory?
It is pretty young. And just looking at transfer speeds alone, they're not coming anywhere near saturating PCI Express 3 by 4, certainly. But they're getting speeds they couldn't get with a by 2 connection. And the jump is pretty big. Like, we're talking about sequential numbers that went from 1450 at the top end of the last series to 2000 megabytes per second. And of course, there are plenty of drives that'll hit 3400 megabytes per second using just, you know, straight NAND. This is obviously different. It's 3D X-point memory. It works kind of like phase change memory. So there's very, very, very low latency. So if you have an application that takes advantage of ultra low latency, depending on the type of work that you're doing, then what you'll see from this is significantly higher random numbers. We're talking about a jump of 200,000 IOPS on QD4 random reads. So, you know, Q depth 4, you know, a lot of lower Q depth numbers are what you actually use on a desktop. QD 1, 2, and 4. And the random read and write performance went up significantly. The biggest boost was the random reads. Random writes went up from 140 to 220,000 IOPS. And the latency dropped, speeds are up. So with that, it's the same endurance. Endurance numbers didn't change. Power numbers got better and worse. At the top end, they're pulling more power. So 5.5 watts is the max now. And it was only 3.5 watts, which is, you know, still manageable. But the sleep states have been improved. They worked on the actual, just like the power states in general, how efficient it is. So it consumes a lot less power when it's not working now, which is good. So it's a nice iterative update with this new M15 series compared to the last one. They're not offering any bigger capacities yet. It's still 16, 32, and 64 at the top end for the gigabyte capacity. So I would personally love like 128 or a 256 capacity and just test it out as a primary desktop boot drive. Not worry about caching, just straight up boot my OS off of it. But, you know, faster throughput is definitely a good thing, because when you were actually transferring larger files on the Optane in the past, that was kind of the problem. You had a smaller capacity drive, and its maximum transfer speeds weren't that high compared to even a mid-range or low high-end NVMe drive. So they're kind of moving up into that faster NVMe territory, but with significantly better access times, lower latency and stuff. So it's interesting. I don't have anything here yet, so I imagine they'll start sampling at some point whenever this is shipping, and we can see what it's like in real-world usage.
Bring on the real world.
Always.
One last thing before we take. Well, actually, you know, let's take a moment to thank our sponsor, SmartDeploy. Oh my goodness! This episode of This Week in Computer Hardware brought to you by SmartDeploy. Allows IT departments to reimage unlimited computer models from one golden image. They offer one-click user data migration for simplified migrations, zero-touch network deployment, imaging over the internet, and application deployment to make your project stress-free. They have technician-built driver packages, their platform packs, and the whole point is to make your life as a sysadmin easier. When you need to support a new model, you just download the pack and you deploy your golden image to any business-class computer. It's sweet, right? This is the most reliable, easy-to-use solution. It's been trusted to deploy over 2.2 million endpoints. That's a lot of systems. It's the first and only solution to offer imaging over Wi-Fi, which means if you have remote users, satellite offices, you do not have to be connected to the same network. You can deploy images, apps, updated drivers to your endpoints via the cloud, Dropbox, Google Drive, OneDrive for business cloud storage. They don't care. They're working with everything here. Step-by-step wizards to walk you through, to guide you through the process. You know, things can get complicated, right? SysPrep, they do it automatically. And they got an answer file to automate tasks like domain join and computer naming. Their goal is for you to have a hands-free, zero-touch deployment. And what gets even better is they're not asking you to take 80 zillion hours of training to make this work, right? SmartDeploy says, migrate 100 computers to Windows 10 in under an hour with out-of-the-box multicast support. The support team's in Seattle. It's full of imaging Windows experts. They're just an email or a phone call away. Some pretty hefty companies, Nintendo, UCLA, Nissan, they all turn to SmartDeploy to make the dreaded task of computer imaging a bit less painful. I bet that sounds nice. Gets better. Gets a lot better. Right now, SmartDeploy is giving our audience 15 free licenses with 1 year of support. That's $720 worth of free IT software at smartdeploy.com/twitch. If you work at a company with 50 to 50,000 computers, head to smartdeploy.com/TWiCH to get 15 free licenses with 1 year of support. We want to thank SmartDeploy for their support of This Week in Computer Hardware. I like things that make life less painful. It's nice. Now that we've attempted to ease your pain with our friends at SmartDeploy, we should talk about Phoronix did a really nice article, really painful to read article in some ways. The performance impact of MDS Zombieload plus the overall cost now of Spectre Meltdown L1TF/MDS. Michael Larabelle wrote this up at Phoronix. I'm going to read the opening line here. Quote, the past few days have begun exploring the performance implications of the new microarchitectural data sampling MDS vulnerabilities, now known more commonly as Zombieload. As I shared in some initial results, there is a real performance hit to these mitigations. And so they took a bunch of systems, and they looked at overall performance impact, and what's going on with Intel and AMD CPUs. Now, this is not all the applications. This is not necessarily your application. This is, certainly not the last word that will be written on this subject. And this is also, as Mr. Larabelle points out, there's a lot of recommendation that you shut hyperthreading down, at least if you're running untrusted code on your system. But even without disabling hyperthreading, the mitigations, the repairs have an impact. And the overall number that was kind of being batted around, it was about 3% for AMD and about 16% on average for Intel. And that's kind of painful.
I wonder if where AMD's AMD wasn't comparing IPC to Intel. I'm like, wait, 15% gains. Right. There's the disparity right there. But no, Intel parts 16% on average lower performance without disabling hyperthreading. So that's IPC with these mitigations in place. So it's going to be imperative for them to have hardware mitigations or design around this to avoid any kind of that's huge. 3% for AMD is like, okay, 3%. It's manageable. It's a low number. It doesn't look bad. And I think prior to this, Intel was somewhere in that 4 to 6% range with the last round of these mitigations. But that is just disastrous. And I'm sure that's workload specific. And I saw some of these. Yeah.
This is Phoronix is a Linux hardware website, or a website that specializes in testing hardware for Linux users. We're not talking about application benchmarks in the sense we usually do, or gaming benchmarks. So I am kind of, there's certainly opportunities for Windows, for looking on the Windows platform and looking at before and after. I do want to call out, this is a pretty intense set of benchmarks when you look at all this, SQL, Redis, Stress-NG. There's a lot of stuff running here, and some of the changes, are pretty huge. Now maybe they're on sort of there's one at the bottom CTX clock, which is the context switch time. Which is this is one tiny little thing that happens inside of the kernel, but it goes from 158 clocks to 1115 clocks. Not a, that's a rather dramatic, like 8x decrease in performance or something like that. And you might be like, it's a tiny thing, but Intel's made a living in the past few years of making lots and lots and lots and lots of tiny changes that added up to a user experience that was more pleasant because everything seemed to be moving faster. And in many cases it was, right? But the whole point of having turbo boost, where one kernel goes flat out, for a second or two, is to make, little things, a lot of little things add up to an overall faster experiences without necessarily having a great big massive processor behind it. Now, I'm grossly oversimplifying even by my standards, but prepare to have a hit for this. Don't be shocked. Be delighted if there's not a hit. It'll be interesting to see some of these systems in the Windows environment, if it impacts Windows in the same way as it does Linux. Given that this is all kind of at the processor level, I don't see why not. But I'm also, as we've discussed on the show repeatedly over the past few years, it's kind of amazing what really dedicated, focused, software developers can do to mitigate the impact or to maximize the impact of hardware changes. I mean, the RTX rollout, for example, went from being an unmitigated mess to, okay, that's not so bad. I mean, they made like a 50% improvement in performance in 6 weeks with some massive driver updates. So be prepared. Be aware. Like I said, I've got some friends that run, some fairly hefty iron server farms, and they're just raging right now, because it's just been hit after hit after hit. Moving in a more cheerful direction, PCI Express 4.0 or PCI Express Gen 4 is basically about having bigger, better bandwidth, more bandwidth. And what better way to demonstrate the massive increase in bandwidth by delivering PCI Express 4.0 SSDs. And the first out the gate seems to be PC Gamer's got an article on Corsair's latest MP600 Gen 4 PCI Express with a big old fat heatsink on it, cooler on it, running AMD's X570 chipset. 4,950 megabytes per second. This seems like a good thing to me. I also, am looking at, moving several gigabytes of data around my system on a pretty regular basis because video is huge. But this is, Gigabyte's got one in the works. This is standard 3D. I'm going to quote standard 3D TC. Gee whiz. It's built with standard 3D TLC NAND flash memory, a Phison PS5016-E16 controller. This is not super faster parts. Paul Lilly points out on PC Gamer. This is literally having more bandwidth. This is taking a major bottleneck out of your system.
Yeah, I mean, the author of this post may not be as familiar as I am with that controller. Phison has shown that controller off. They showed it at CES, and back then it was hitting about 4,100 megabytes per second. They haven't released a data sheet on it yet, but the PS5016-E16 is capable of up to 5,000 megabytes per second, so nowhere near saturating PCIe Gen 4, but certainly significantly higher than we can get with PCIe Gen 3, where the drives are topping out somewhere just south of 3,500 megabytes per second, I believe. Even though, in theory, you could go higher than that. We never fully reach the limits of any storage bus because of overhead. But, 4,950 megabytes per second is significant. That Phison controller is an 8-channel controller. So between whichever type of memory they're using, and Corsair did not reveal what 3D TLC that is, if it's something from Samsung, something from Toshiba, but we have a little bit more information on the Gigabyte drive that was announced shortly after this, using the same controller, because there really is only one controller right now. I know Silicon Motion had been working on one. It was on their product roadmap I think all the way going back to CES 2017, they were talking about that controller. And another thing that's common between these two devices, the one from Gigabyte and the one from Corsair, is they're using very, very big heat sinks. The Gigabyte heatsink is actually a pure copper, like wraparound heatsink that completely encases both sides of the SSD. So these are not mobile solutions at all. These are going to fit into a desktop, and they need some vertical space, and they need some airflow, because apparently this controller gets quite hot. Talking about 6+ watts on the controller, which is, I mean, we talked about 5.5 being a little high from the new Optane. 6-7 watts or more from this is pretty significant for an SSD. So, and the performance of that Phison controller, at least according to Gigabyte specifications, is being fully exploited, because the Gigabyte drive is rated at up to 5,000 megabytes per second, which is the exact specification from Phison. And then the RAM, or the NAND that's being used, there is a RAM cache on this, but the NAND that's being used is Toshiba's fastest flash. It's TLC 96 layer 3D stuff, and it's capable of up to 800 megatransfers per second per die. So they're making the most of this. Like, we're going to see significantly better stuff soon, I'm sure, once more controllers hit the market. I'm sure Samsung will have something, as they always have. We'll see maybe something from Intel, but who knows, because they don't have a PCIe Gen 4 solution. They're still on Gen 3. And, the roadmap, I think, has them going to Gen 5 next, basically leapfrogging this. And I didn't add it to our list, but the Gen 5 spec was officially ratified. I think they published that yesterday. So even fast, it doubles the speed, the effective bandwidth of PCIe Gen 4 already. And that standard, is a day old. So really, really interesting to look at fast storage, though, because if you look at the X570 chipset, well, what's the advantage of getting a 570 if I already have an X470 board? And AMD is fully supporting the 470 across the board, and their partners are releasing BIOS updates to support the new processors. Well, this is one of those things. Once these drives are available, once we see pricing, because the other thing is, I think these are higher capacity drives too. The Gigabyte is either a 1 or 2 terabyte capacity, nothing lower. And I assume the Corsair will be somewhere in that 1 to 2 range as well. If for no other reason, then they're using very high capacity flash. 96 layer 3D stuff is not low capacity, and it's an 8-channel controller. So to get those speeds, they need to use all 8 channels, thus high capacities. So
nothing wrong with that.
Oh no, I want bigger and faster, so I'm totally fine with this. In fact, I think it was Gigabyte who has a 4 PCIe Gen 4 by 4 card, an expansion card with a fan. It looks like an AMD reference card from like the Radeon 6000 era or the RX 400 cards, but it's monstrous. And if you imagine, like, that's what you could do with 16 lanes of PCI Express, just put 4 of these SSDs in it with active cooling and get yourself about 20,000 megabytes per second. So 20 gigabytes per second of speed.
Interesting. A ton of additional hardware announcements taking place this week. One of the ones that stood out, especially for you, Dell's XPS 13 2-in-1, changing the aspect ratio to 16:10. They've got a UHD plus option, active cooling, which I think is an excellent choice.
Very much, yes.
Is this going to be the first system we know of, or the first system we see with 10th gen Intel Mobile inside?
It was the first. Yeah, it was the first one listed, and in fact, that's where I was getting product names from first. Their spec sheet shows these new and unusual product names, because we were into the 9000s with the latest Coffee Lake stuff, and they have gone back to the 1000s apparently. And Dell lists the processors in this XPS 13 2-in-1 as 10th generation Intel Core i3 1005 G1 the 1035 G1, and a 1065 G7, which is a Core i7 part. So it's i3, i5, i7. And I don't know specifically what those are because they don't show up anywhere. If you're looking for like an S-spec number or an entry on Intel's site, they're not there yet. So we'll have to get some clarification from Intel and or Dell, maybe under embargo, who knows. But it's, the specs are good. And this laptop in particular, the specs are fantastic. If you like 13-inch, like very compact travel machines like this, and I favor 13-inch because you're sitting in coach. I can't imagine trying to negotiate a 15-inch laptop or larger, but this is an improved design all around. They talked about how they made it thinner, but at the same time they made the screen bigger, and I love the fact they're going with 1610. Especially if you're working with documents and things, having more vertical space is you want that. I miss the 1610 monitors, and it makes me sad when even like professional level monitors having a 16:9 aspect ratio. I just kind of sigh. Because unless you get a really big one, you're not really doing side-by-side documents on that. There's just not enough space. I tend to turn my 16:9 monitors 90 degrees and have like a horizontal monitor off to the side. But the active cooling is huge though, and it's funny.
Yeah.
They're shrinking the chassis and adding active cooling. The previous generation of this 2-in-1 from the XPS line was using those Y series processors, very, very low power processors from Intel, not really high performance at all. And just by going with active cooling, they're able to put in, some of these parts. I don't know if they're using like the 9 or even up to the 18 watt parts, but faster clock speeds across the board. Active cooling means it'll actually run at higher turbos for longer periods of time. So it's all good news. They're saying 2.5 times, the performance of the previous generation, because this is the second gen of this XPS 13 part.
I mean, something I've been playing around with, to go back to kind of the active cooling is I've looked at 3 or 4 laptops in the past few weeks, and it has been interesting to me to see newer, faster parts that are not necessarily outperforming older, slower parts. And a huge part of that just seems to be the thermals. And it was interesting because I was looking at a what should be, at least at the bare minimum, a slightly faster part in another brand or another manufacturer's system, and seeing considerably lower performance. Now, part of that may be, the newer system had just been released. There's maybe some questions about whether or not the firmware was final on the model I had. So I'm still investigating, but I just want to throw this out there. Dell with the XPS, series especially, they've been really, really good about delivering as much performance as they can wring out of the processor. And I'm really, really okay with moving to active cooling. I am not a fan of passive cooling on laptops at this point because the TDP of most parts leads to, in many cases, especially on the Surface Books we saw, was leading to thermal saturation and radical decreases in performance. So I just wanted to spout off about that. I'm still collating data, as they say, to borrow a line from a certain series. But Dell's done a lot of stuff to try to figure out how to isolate heat and how to get heat out of their systems as they continue to figure out ways to keep them thin and light. And I just want to say, it has a real world impact. You may not notice it if 98% of your life is, applications inside of websites, and the occasional massive spreadsheet. But if you compile code, if you edit video, if you edit audio, if you get Photoshop on, there's a real world impact to an inferior cooling system. And Dell seems to be really hardcore about, doing what it takes to actually get the performance the processor is capable of out of their ultra portables.
Yeah, that's all. And I personally don't even care that much about the ultra portability. I like the smaller form factor, but I would take a thicker laptop for better cooling for the exact reason you're describing. I want those sustained boost clocks. I want to actually get the performance of that higher end part. Why pay for a mobile Core i5 or i7 if it's going to be running at lower clocks because there isn't the thermal dissipation capability from the chassis or if you're in a little thin and light aluminum notebook that has no active cooling, you are the active cooling because you're going to be touching it. It's going to be on your lap, and anybody who's used one of those NVMe enclosures, like the little metal, like USB-C enclosures, those get hot, and they have to because the enclosure itself is the heat sink for the drive. So,
no, I'm thinking of a particular SanDisk USB drive I have that is alarmingly, it's tiny. It's got 256 gigabytes inside of it. But oh boy, does that thing, you transfer 6 or 8 gigabytes onto it. And, I love the fit drives. I love the ultra fit drives. But, I think about a lot, writing to, SD cards, micro SD cards, thumb drives. There's a lot of heat generated when that happens. And there's also a lot of heat generated when you're cranking out clock cycles on the inside of a laptop. So, We have one last story. Something
last but not least.
Last but not least, something I am surprised yet not surprised. High-end cooling, the really sophisticated stuff that you see at trade shows and at events where somebody's done this amazing neon day glow, piping monstrosity of joy and wonder. This is not the kind of stuff you find traditionally at your local Best Buy or even your local computer store. You're usually, online searching and then doing a lot of fabrication. Corsair's Hydro X series is trying to make custom cooling easier. There's a trade-off. It's certainly not going to be the least expensive custom cooling you have. But if you take a look at these pictures, you might be salivating with intense desire and wants, right? RGB lighting, of course, CPU blocks, GPU blocks, pumps, reservoirs, radiators, tubing, fittings. And I think a huge part of this is the custom cooling configurator. Design your own custom cooling loop with the Hydro X series. And, you pick a case, you pick your motherboard, your CPU, your GPU, and you just keep working through this. And eventually, you get a recommended setup. And, according to your entered PC configuration, we've created an ideal Hydro X series custom cooling loop for your PC. This is fun.
Yeah, as you're talking, I'm going through with their configurator, their custom cooling configurator on their website, and I put in just a basic build with some of the stuff I have here. And to do kind of a medium range cooling solution, it's over $700 if you're buying everything, because they offer all the stuff. And if you're buying from them with this configurator, you need to order the parts. They'll do the recommended parts. And they'll do the required parts. If you're just going required, I think the lowest I could come up with was just over $600. But EKWB, if you're interested, if you're in the world of liquid cooling, like custom loops, about them, EK water blocks. They have a similar system already. They have a website where you go and you can configure a new loop. But their parts, at least the ones that are recommended by that configurator, are a little bit more expensive. So that sounds really, really high. Like $600 plus for a cooling system is very expensive, but custom cooling is not cheap. And EK water blocks, their solution when I ran it was around $100 for the CPU block, and their GPU blocks were $159. The Corsair blocks are $75 to $80, and the GPU blocks are $140 to $150. So they're not overpriced. It's just that you put the total package together from scratch. It's not cheap.
I mean, and we should point out that in many cases, unless you're doing some fairly obscene overclocking, you are not going to see a real performance advantage going with a liquid-cooled system over an air-cooled system.
No.
Yeah. I'm also laughing because your $600 price seems pretty reasonable, because the setup I worked out here with a single GPU rolls out to a nice steady $880.82 with $160 in fans.
Oh, see, that's the key. Changing the fans from RGB to non-RGB. In fact, that's where a lot of the price savings came from. I was turning off RGB where I could, and still, in that $700 range. I know. I don't know why you would. I was just seeing how affordable it could be. But when I saw that number, like, well, this isn't affordable anyway. So if I'm spending $700, why not spend $850 and get more capabilities? Throw an extra rad in there, make everything rainbow effect. And it kind of depends on your case too. They ask you what case you have, and because this is Corsair's, they're asking you which Corsair case you have, of course. But if you're starting from scratch with one of their like Crystal series or one of the carbide cases with lots of glass, and you want to really show off your system, and you've seen like overclocking, and you've seen the YouTube videos and the stuff about the mods, the hard tubing, all that stuff, and they have hard tubing available too if you want to do that. But it's a easier, more accessible way of at least putting together a kit to do this yourself and have one of those amazing looking systems. Like the systems on this product page look unbelievable. Like they're incredibly clean, beautiful lighting. You don't see a cable anywhere. It would take a lot of work to match what they have on the page, but it's certainly doable. And I don't know, that amount of money coupled with, of course, whatever you're combining it with. So if you're doing a Core i9 9900K with, I picked the RTX 2080 Ti Founders Edition card, which is somewhere around $1,300, I think, $1,100 to $1,300. These are not inexpensive builds, not inexpensive cooling, but like you said, put a big air cooler on your CPU. And unless you are doing
$35,
unless you're doing serious overclocking, you are not going to see a real world impact because the CPU will be running well within its thermal spec, boosting happily along. And especially if you put a bigger heatsink on. Like I like heatsinks in that like $50 to $60 range and up. I've seen really impressive stuff from Scythe, from Be Quiet, from of course Noctua, but these are coolers that are very, very hard to hear because the fans are spinning at very low speeds and they're relying on the size of the heatsink. But tower air cooling is very hard to beat. I think where this really gets interesting is GPUs because something like the Radeon 7, they don't have a Radeon 7 block yet. Their only AMD block is for the Vega 64, so I'm sure that'll be updated. But those are not quiet. The Radeon 7 is over 50 decibels under load. So if you're worried about noise, you could pair some extremely low RPM or very, very quiet fans with radiators and do a custom loop. And that was one of the appeals of the custom loop back in the day. Get away from those screaming 60, 80, and 92 millimeter CPU fans.
Right.
And in that generation, it was going underwater was the only way to have a totally silent build. And that's changed a lot with a lot of these bigger cooling solutions that use, 30 decibel whisper quiet fans. But it's still, there's nothing cooler looking to me than I go to these shows and the booths always have incredible custom cooling loops because that's how you showcase your parts, whether it's memory or cases or motherboards or whatever it is. They always have custom loops. And in the last few years, it's always been just RGB everything. And it looks fantastic through a tinted side glass panel. So
not that you're excited.
No, not at all. I'm calming down. It's okay.
A little bit. Oh my goodness. That, ladies and gentlemen, pretty much wraps up our Computex 2019 coverage. We'll be cherry picking some of the announcements because literally there were dozens and dozens and dozens of announcements this week. We have a ton of hardware news coming up between now and July. July is going to be huge because of the release of the 3000 series, the 5700 series, and anything else Intel, AMD, or NVIDIA can jam out in the time being. I think we pretty much know what's coming from AMD. Next week, we might talk a little bit about some of what's going on with AMD's next generation APU for consoles. But for the moment, we're going to take a break, move on. Well, Sebastian's probably got some benchmarking to do for
take a break.
PC
what world are you living in?
I'm living in fantasy land. I've got a episode of AV Excel to edit and my last episode of Tech Thing to get working on. And as always, I want to thank each and every one of you for listening and watching This Week in Computer Hardware. We call it Twitch. twit.tv/TWiCH is the best place to find our show, all the Twitch shows. Well, not all the Twitch shows. Go to twit.tv for all the Twitch shows, but twit.tv/Twitch will get you all the information you need to subscribe on pretty much anything you might ever want to, the video or the audio of This Week in Computer Hardware. And this has been episode, goodness, could it really be 519? It is, ladies and gentlemen. Yeah, if you've been thinking about buying a new CPU and you need all the power, do yourself a favor and wait till 7/7/2019 when we see the numbers of the 7 nanometer. I'm just trying not to make 7 jokes. Ryzen, next generation Ryzen processors. Yeah, ton of news coming up, so keep posted and we'll keep making the shows for you. With that, ladies and gentlemen, I'm Patrick Norton.
And I'm Sebastian P.
Catch you next week on Twitch.